Welcome to another video.
Hi, Lana.
So in this video, what we're going to do is we're going to talk about trigonometric identities. Super useful, super challenging sometimes to prove them. And so we're going to start
So
with
let's
this video with just an
assume.
introduction. So the
Do
basic
you want to be the Reaper? Or
basic
do I want to be
identities
the
that we
Reaper?
have
Well,
that we're gonna use
whatever.
later on to
You know, the
prove
identity
identities.
that we choose
Like,
to sine and
here.
cosine this
Sometimes we
thing.
get into this, like, thought
I'll play the
process,
devil.
like,
I'm not afraid.
teachers are just
I'll do
trying
it.
to make our lives harder when they get to this identity.
I'll field theory
And
like
you
a
might see it that way
dragon,
because
heal
they're
hurricane like
But
the
really
devil,
will make your
whatever,
lives easier
whatever.
when you get to Calc 1, Calc
You know,
2,
if we're gonna
3,
use
and
that
start
as the
with
tangent here, as
trigonometry.
far
And
as
some of these things are very
calculus,
difficult if you don't have
trigonometry.
a grasp of identities under our belt. And so we're going to start that
So
right
we
now.
just got
So
done
I'm
with
gonna
Nikki's news a
refresh
second ago. This is
what
first
our
shot.
identities are,
Go at it, Len.
even the Pythagorean identities,
Love the
so
math.
simple identities.
I
We'll
love
use
the
them just a
Masons.
couple
I
examples
love
right
what
now,
this
just
does.
trying to get your
What's
brains
so
wrapped
difficult
around
about
how
it is
the world
trying to
structure
explain it to
prove
people.
identities. How do we simplify
Like,
these things with trigonometry? Because sometimes
it's an apple.
not very obvious.
It's an apple.
So we're going to start that
Yeah.
right now. So some identities that you
It
should
doesn't
have,
roll far from
yeah,
the tree,
those
sine
are
and
they're on
cosine.
a
If it's on a flat
That way you
hill
associate
or
the
flat
name with
hill
the
in a
that way
valley,
when
you
get
know,
there
those
to,
are sines and
actually use
cosines.
them,
If it's
you're not
gonna
flipping
roll,
through
it's gonna
yours
go
all the
that
time.
way.
Also,
But
I
do you
have
understand
written
how
down the
fast we
orders
just
to
went
begin
there?
with. But there are different ways you can write this, like the Pythagorean identities. We'll talk about that.
And you gotta
So here's the
get
basic
comprehensive
identities that
about
you need
it.
to at least be aware of,
Again,
and hopefully
what
know how to
this
use. So the
isn't.
reciprocal identities are important.
It's
They
more
do
for
things like
students
tell
in the
you
way
that
to
tangent can be
perceive
represented as a fraction,
a
sine
process.
or cosine.
This is
Cotangent can be cosine
when
or
you
sine.
ask when somebody asks, or what was the statement back in
Those
the
are
day?
all very important. Cosecant
You
theta
think
is
you know
1 over
Carl
sine, and
Sagan.
secant theta is 1 over cosine. Those are all
There's a
our
few of us that
reciprocal
could
identities.
be
We can
Carl
write
Sagan.
sine and
Now,
cosine as secant and cosecant.
when you
That's
get into the
typically
college
all we
level
do.
class of
I'll
that,
give you sort of a heads
or
up about how
designing
identities work
certain
as soon as we
classes,
make
like
this.
especially the stone
The
mill, there are
Pythagorean
so
identities
many
are these
totalitarian
guys into the
universal
squares
Carl
then.
Sagan
So
loaves that
two
you're going to be
squares, they
doing
cross
Penzero
equals
twister
one.
theory through.
So sine squared theta plus cosine squared theta
You're going to
equals
field
1.
theory
That's
like
true.
a dragon at
It's
some
Pythagorean
point in
identity.
time. You're
What
just
I'm
going to start
not writing
talking,
down
and
here
it's
is
just
things
going
like,
to
remember
burn
that
everything
this is
down.
true. I can subtract cosine squared theta from both sides and get sine squared theta equals
How many
1
people are
minus
actually
cosine
lost?
squared
Well,
theta.
I don't do it
Likewise,
because
cosine squared
I
theta
look at it
equals
from the
1 minus
mathematical
sine squared theta.
concept.
I'm not
Here's
writing
a
those down. That needs to
from
be,
sine.
I would say,
Here's a
obvious,
cosine
but it
in
needs to be accessed by
esoterics that
understanding.
is
That's
the seal of Solomon, or the lesser key of Solomon. Oh, we'll get into a squared circle problem here in a little bit that's got some wiggly squiggly internal momentum and spin to it that, oh boy, that's got some charm, let me tell you about it. And that's my general command directive. Beyond this point, we will begin to cover the concepts of force of a frame force of a frame in motion, or NP complete, the fixed value against the relative form time space quantum AMEC. We have no values right here, none. In other words, I like to say this is how many of you are Evel Knievel that actually did the math to graph the weight of the motorcycle, the weight of you, and the speed down a ramp to jump the Grand Canyon. That stuff is practical, but if you don't know what that stuff is, this stuff helps you kind of figure out the form ratio. The problem with that is there are many mathematicians and everything, and you're gonna get ground down into the ground about, not me or Leonard. Hopefully we do this correctly enough where it doesn't matter where we go. Gresham's law for Bernoulli. Inside of here, Bell's equality is going to be Dirac's equation popping up. There is so much diversified inconsistency and diminishing return of field theory's dead, general relativity's dead. We have to deal with his apprentices or somebody that he considers to be an equal in the field of a relative topic, but in the reality of it, it's going to be very comprehensive from E equals mc squared. Why? T.
If you have more than one fraction, try to write them on the same denominator. So try to combine your fractions.
Now it works because gravity works. We all agree A is A, B B is B, B, and that applies great. Jump the pond for me, would you?
So the ones that you know are true. I'm trying to make them
Now,
identities.
by metrics and standard, imperial and standard and imperial, a meter is 1 yard, right? So 100 yards is about 100 meters, something like that, closely to that ratio. A kilometer is about 3, an inch is 2.45, I do believe, and centimeters. But they are congruent. They are A and B congruent. Sine and cosine do that. But the thing about that is sometimes the value you get might be in inches of treads, and then somebody's going to give you a value in a different form, and you got to figure that out. You know, in the stone mill, it should be all the same numbers, but they're not going to be in that way the same number. The cosine there is going to be one that says the inverse square law, 4 pi, and I forget what the algorithm is exactly, but we could certainly use 2 over pi, or pi over 2. No reason that can't work. The only problem is we're trying to fight square law. We're trying to figure out what system that did. Without inputting any numbers, that's why this system still works. Otherwise, you would jump right into square law. You would jump right into 1 over sine. What do you mean 1 over sine? This is a bit. Bits and bytes, high, low, but basically we're saying the only thing that matters is this number right here. This is one frame. Could be this one. Could be this one.
And usually we'll have something cancel out. As it always happens.
And from that, we're going to use that as sine. We're going to start to cross multiply this, sine times sine. They cross themselves out, so I basically have 1 over the cosine. I have one number over that angling angle that correlates to that value in that form, right? That's what I see. I don't know whether he could. It's really hard to quantify that. So I use Brinken-Dreyer's conjecture. It's actually Brinken-Sandeyer's conjecture for the stem problems. If you use it on college, this guy will throw so many symbols at you. Greek, Latin, all in the same theory. And you have to make money out of it, right, Leonard? Now, I want you to understand what I've done in the safety briefs for the stone mill was essentially my Brinken-Dreyer conjecture about weekly, bi-weekly, and monthly rotations of Sawyer's maintenance team and management, or the idea that once I have that fixed form, a manager can go to a mechanic, or a mechanic can offset these things if the time is congruent with those systems. It gets very heavy. Most of you have none of these forms done. None. There is, what, Trig 23? 23 of these run in for 23 minutes. The big end on this one is going to be Pensrow. He talks about it in a 45-minute theory on Twister's theory. Now, we all know the one good general out there, Sarge Mage or something, that said you got 5 minutes. 5 minutes to impress me with this thing. You're going to compress this information. It's a pressure gauge. You're trying to determine field theory and trigonometry identity of what it is. Well, firstly, there's a history to it. I don't know what class you came from. I don't know whether that's a standard model or an adjusted model through the earth or around the earth. We use an apple or a pomegranate. Gonna go life right. Making her happy while I'm building Shangri-La over here.
Lucidchart makes intelligent diagramming easy and helps
Eventually, you're going to get to real values. They actually have some real numbers to the outputs on those things when you look at some of those cut coefficients. Team, Three-Finger Joe and Bob on day shift, they clocked in at 6. Offloads are at 6:30. Offloads start 6:30. Number of pieces, 23 pieces. Number of cuts, 33 cuts. We have a front and a back. That's actually how many good ones were pulled out. That gives us block yields. That gives us things, we'll keep going here, saw off at 7 o'clock, so that gives me an average. Now, if those saws are loaded all the same way and I'm using the same machinery to get it, I start to build a rough average of what the saw coefficients are. Number of bad pieces, 4. And then you can kind of look at this and say, well, that's what I've been running consistently. When I get 0 pullouts, either that's going to jam up that tread line, or they're missing cuts on the skins. So I'll go out and I know exactly the vector position on the planet is to check one of those 2 places in superposition. I know it has to be there. That is where it has to be, given the tangent on this of the sine, and therefore the cosine would be the result of either that tread line or the block pile when I go through looking at stuff. Those numbers will actually compound later on to other things at phases of years, raises, promotions, terminations. And that's what makes it fair, because we actually have a valued graph. And it's one thing to say, all right, now that I've done that, I have to train first. I have to train these guys first on that before I fire them. I can't discipline somebody for something that they're not trained on. But this gives me an idea where to train them instead of back to the book and how long this will take you. Well, this could be up to a 5-year, well, this could be a doctorate, but I've been sticking with the Master Mason, or the Mastery. If you want to associate with me as a bachelor, stag, you know, you're going to have to come up with me on that. Now, you might be bigger and prettier than me, Leonard, but I'm dangerous when it comes to your old lady. We gotta work that out before we just. That's the game. Okay, this is a Terminator gambit of certain frames. We could have made a turbulent flow from here. Now, why? Because there's a real Bernoulli's number. What if I actually started programming that? Are you going to get into the 0 field of what it is, or 0 and 1 field of it what it is? Or are you going to actually find the tangent? The tan equals sine over cosine. This many cuts over this time. The cosine would be the time of how long that takes over this. So basically we switched off this position and we've compressed it. I don't know exactly what the term is on that one, but there is a term for it. And we're calling that 1 over the tangent. That number for that result of cuts over time as an average is 1 over tan. That's 1/2 of the problem of the stone mill in general. Now that is still but a fraction of the problem, but as we describe this problem out front, where you got to stand your feet. Oh no, saw program's just over there in the other corner of the building, right? No. Thermal and rock is just one of those things. How this saw program works is, well, here's a little Jacobian matrix, but they're all the same thing, right? I'm loading a block, loading a block, loading a block, a block, a block. So the whole block is all of those blocks. But you don't know if I'm doing it in series or if I'm just talking about that last block as you're programming it, or the way that orientation is.
You can't add and subtract fractions if you have a different denominator, even if you have trig functions.
You can't add or subtract fractions.
You just want to make that sine plus.
Well, not.
It doesn't work. They have to be.
They're 0 and 1 fields. If I had 1/2 minus this, what sense would it make? Well, if I say half the time instead of a number, a fraction. A time is a fraction in its entirety. It's a t note. It's a t in the equation for Schrödinger. It's one of those things. A lot of people don't get that. If there's a faster way for me to do it, I'm gonna jump on it. It's.
I hope you're listening right now, especially if that's a minus. Then you have to distribute that. It would change your sign. Doesn't here, but in general.
This is tighter. I'm going to admit that this is a lot tighter. The problem with it is it always ties to hydrogen, or actually durium, helium, or durium, hydrogen, tritium. And then this whole fusion reactor becomes a drunkard walk problem of you trying to actually. There are real things in there that's what that does, but we could subtract that. But it's still going to be in this original form of this first part of the progress. So as you progress through the steps inside here, this would be a positive function. But we can do it negatively. The problem is time works right-hand rule, even if we go back in time to determine the value of an incident.
Like if you have this, of course you're not going to want to change that. sines and cosines, but in general, it's
Let me give you a visual.
make one fraction.
Okay.
Make everything sines and cosines.
So they're
if you're
equal.
Not seeing an identity already.
They're equal. IH,
Then
fair
simplify
enough.
what you can.
But it'll actually go
And
from,
then
what is
find
positive?
identity, we'll just put it
Which way is positive inside of here? On scale. Which way is positive? How about now? Which way is positive? Well, yeah. Which way is positive? The counties or the
Okay,
road
So
system?
I've done all that. I've made one
Well, if
fraction.
you're just in this work in the
I
county
made everything
budget,
sines and cosines if it wasn't
yeah.
already. It was.
What if
I
you're
simplified
over
what I
here in
can,
just the
that's
town
great.
of Hancock,
I've written it
right?
down
From
precisely that
Delaware
also
County.
is one fraction,
What's
and now we
positive?
try to
What's
find
up?
an identity. If one didn't show up before, we have to find it now.
Alright.
So
Catch
sine
you on the
squared
next one,
theta plus cosine squared theta.
Love the
Let's
work,
look
man.
for
You know I'm
something
gonna
that
catch every
resembles
one of them.
that. Now remember, it doesn't have, this, I just gave it to you.